In this video, we're going to go through our code for our Rapid Relay Xdrive. Hopefully this can get you jump-started for future games to help your robot move easily around the field. First, an Xdrive has motors at different angles so that it can move in all directions or rotate in place. To move forward, we spin all our motors forward, and to move backward, we spin all our motors backward. To move right, we spin the front left and back right motors forward and spin the others backwards. To rotate right, we spin our front left and back left motors forward. For more info about basic Xdrive controls, see the link below. Don't worry about rotation adjustment and speed cap for now, as we'll get to those later. Now we'll go through the PID controller we use to keep the robot at a target heading. We start by calculating the error between the heading we're at and what we want to be at. Then we scale this so that it's between plus 180 and minus 180 degrees. We set this to 0 if we're not adjusting heading, like before the match when the robot shouldn't be moving. Then PID works by using 3 values to control robot rotation. The proportional term rotates the robot in proportion to how far away from the target heading you are. The integral term builds up small errors over time so that you're not stuck off 1 or 2 degrees, and the derivative term reduces speed more as you get closer to the target heading. See the link below for a more in-depth video on understanding PID. Next, we need to be able to manually turn the robot. If our controller is outside a dead zone, we set manual spin mode, which uses the controller inputs later on to control the rotation. But if we're in the dead zone and we were manually spinning, we hold the motor velocities where they are, other than the rotation portion, pause for the rotation to come to a rest, and then set the new target heading for the heading we're at. We also used Field-centric controls. This means that when you push the movement joystick away from you, the robot moves away from you, regardless of the heading of your robot. This uses some trig formulas to rotate the inputs from the movement joystick relative to the heading of the robot. We subtract 90 degrees because the robot actually points to the left instead of straight away from us. Because we are loading balls in the front from the left and scoring out the back of the robot to the right in Rapid Relay. We also need to make sure that we don't just tell all the motors to go at 100% velocity, because we're giving them multiple inputs. So we used a series of if statements to find the highest velocity we called for, and then scaled that down to 100%, and then scaled all the other motors down by the same amount. This lets us give multiple movement directions at once without them getting mixed up, so we can move and spin at the same time. We also used a distance sensor and 2 buttons to automatically align our robot at a certain distance from the wall that lined up with the near or far goals. We calculate the distance from the wall using a trig formula, because if the robot isn't lined up with the wall straight, it will think it's a different distance from the wall. We simulate the controller position using this basic P controller. Just like this, we move our robot in autonomous mode by simulating controller positions and calculating how far it has moved, rather than trying to do the calculations to try to set positions that involve movement and rotations. Now, to move in a straight line in autonomous, we just send the velocity and distance to this function along with a timeout value. We simulate our controller being in a position to get the velocity we want, and then we just track the position of one of the motors spinning. We also have a function that moves in a straight line a certain distance from the wall so that it will align with the goals perfectly. The only difference is that we set the A position of the controller, and that our condition for the repeat until adjusts until we're almost at the timeout or distance, so that just in case things are a little off, we can use our robot aligners to get to exactly the right alignment. This is how you can code an Xdrive in a really advanced and effective way, and hopefully this helps you in future seasons.